Okay, let's continue our train of thought from last time. Remember, we've been digging away in chapter 22. Okay? And we've been looking at the enolate ion. Okay? Today what we're going to do is chemistry of enolate ion for what we call the aldols. Chemistry of the enolate ion for aldols. Okay? You don't know what aldols are, but we will very shortly. Okay? So let's put this molecule up here. And let's react with base, OH minus, and water, and see what we get here. Okay? So the first thing that will form is the enolate ion. Okay? Can somebody come up and draw the first part of the resonance structure for that enolate ion? Okay. Looks like I'll have to pick somebody. All right, let's start up front here. Why don't you come up? If you can't do it, I'll help you. Pull off the alpha hydrogen and draw the first structure here. You don't have to do the mechanism. Just draw the enolate ion here. So, what do you do in the enolate ion? You take off an alpha hydrogen. So let's take one off. So that leaves us with 2 here. And that leaves a lone pair here with a negative charge. Okay? Keep that hydrogen there. Okay? So that's the first part of the enolate structure. Who would like to draw the resonance structure for that? Okay, Laughlin? We'll get you later, George.
Okay.
Very good. Okay, so resonance structure, again, dumps the lone pair in, and these electrons go up to give you O minus. Okay? So these two form the enolate. Okay? Which one of these two, do you remember, serves as the nucleophile? This one here, the one that has the carbonyl. Okay? This is our nucleophile. What we want to do now is react with a new molecule today to form what's called an aldol. Okay? So our new molecule that we'll react this with is going to be another molecule of the starting aldehyde here. Okay, so we're going to bring a second one in. Okay, so these reactions, you'll see we'll have a 2 out in front because we're reacting 2 of these together. Okay, so the first one forms the enolate. The second one is going to react with the enolate. Where's it going to react here? At the carbonyl. So it comes there and pushes those up there. Okay? So just basic aldehyde chemistry. So let's put these 2 together. To give us that structure there. Okay? Make sure you follow this along. Okay? So the nucleophile carbon adds on to the carbonyl. Then lastly, we'll bring in our water molecule. What is water going to do here? What's this O minus going to do? Take a hydrogen. And so we get this for our final product. Okay? So make sure you have this in your notes. You're going to be using this as a model shortly. And this final molecule is what's called our aldol. Why do you think that's called an aldol? Yeah, you've got an aldehyde and you got an alcohol, so we blend them for the aldol. Okay? Basically what aldols are simply the OH on the beta carbon. Okay? Here's the alpha, the carbonyl. So I got a beta OH and a carbonyl. That's what forms an aldol. So we'll see an aldol can be called an aldol no matter if it's an aldehyde or a ketone. Okay? As long as I have that carbonyl there. Okay? Any questions on that? Okay? So now what we're going to do for the rest of the bulk of this class is I'm going to give you some reactions, and I want you to work on those together in a group or pair up, something like that, okay? Because these things are a little tricky to do, okay? So based on this as the model, let me draw some reactions for you to do. Okay, let's try these here. do these three. And go ahead and proceed to work in some small groups and derive the answer, okay? You may want to do the mechanism for each so that you keep things straight, okay? So give these things a try. I'll be looking around to see if you're on the right track or not. Work with a neighbor if you're lost. Don't just sit there. Help each other. It's not easy.
You gotta fulfill the intent for the six for that first conference. I just want to make sure I'm doing it right. Well, I went on to the next one. That's the chapter.
Hey, was there anything else on the board, like, just on the list? Did y'all have anything before the commission?
Whatever you want to do.
No. Which one?
Trying to change this to this. Oh, this to this. Which one is that? This one to what? This one? That's the inlay diameter.
When you have no double too?
Does you have to make the inlay diameter? Hydrogen still.
I'm listening right.
This long camera is here, and this one's in front.
Oh, I just
So
got
that's
the
the
right.
front line, and this is the next.
So
Up the
it's-
left.
Okay, then pull up an alpha hydrogen. Where's the alpha hydrogen over here? Alright.
Up left.
Like I usually, so I just took off the higher than I did.
Back in
But it
there,
made me
so one of these bonds
CH,
go up,
and it
make
still
the line
stays CH.
itself. And draw the result of all that.
Yeah, I give those some.
About two.
Like, so you don't necessarily have to change this one
One is
to
that
CH2. What is this talking
Oh,
They're just
the
saying
tools
you
with
want to do
tools.
twice.
Yeah.
Like,
What's going on back here?
okay, I got a question. Right here, we can have it like,
That's right.
okay.
So now have this attack, carbon
You doing the second got the worst of that?
Okay.
So, like that.
Okay, but yeah, does number two is just showing you when you get ready to do the Aldol part, you're gonna use this a second time.
So this is that. Now
So you supposed to be-
that's here.
Right.
Mm-hmm. Like when you get, when you get ready to react, you're gonna use another CH3.
Second carbon.
I know. I feel
You rearrange.
So did you end up with the CH3, CH2, CH, CH, CH?
Next there, so you rearrange.
That's the whole mechanism.
Yeah, so you just had to choose one side. Oh, you know what?
Because don't you, okay, when you added the second one, you added the same thing you did for this one. I know something, so you started off with this. Okay. I got it for this one. I see. Then we're gonna add this one to it. She ain't taking back.
I want to see to have two in the original drug. Oh, okay. I see what you're saying.
So, we can still attach this CH3 right here?
You have to. I really don't understand the mechanism. When this text is, what happens? This text is, you use CH3, CH. So the second part. See, that has two. But you know, when this text is carbon.
She's gonna knock
This
out
line
the
is
first
color.
one.
Okay, so that's how we get this. And now what is CH2, CH? We just add this back.
This one I'm stuck on.
Oh, okay, I get it. I'm gonna show you how to do this next. So it's 2CH2. This how we're gonna do the next one then.
Okay, first.
Hold on, please. CH3. You just let me know if I'm doing this wrong. Then we'll explain it together.
So you added
That's
CH
CH3 plus H2 yields what? First thing we have to do is make the analyte ion. So it's
Yeah, because you don't have to test it.
2CH3 plus these two here anymore. CH3 is going to do what?
I do the resonance first.
You're going to lose one of these, which turns this into H2. This is going to move in, which gives you the analyte ion CH3 dash C minus.
So that carbon right here
This is the one that attaches to
The nuclear file with carbon
Right. So come back on
two.
It's gonna change. Then a long period, we're gonna take this carbon. This right here is gonna take the carbon.
Very good.
And then you're gonna knock out the long
Three.
Good, we got the enolate.
this carbon.
Wow, I don't know.
That's not possible.
That's what I was saying, like how did you see it?
I think CH2 is what's going CH3, Oh, we forget the stuff.
Did you get the first? Show her what she's doing wrong.
Is that a long period?
Show her your problem first.
KG. connect this with this to the focus.
I get it, why?
So you gotta take the hydrogen off, so there it is. Attached. Well, this whole thing is attaching to there.
Oh.
So take this CH3 off.
No, it's there, it's safe. Now bring that and attach it down here.
Oh, so we don't necessarily have to attach it right next to it. We can attach it to
As long as it's
the
on,
carbon.
as long as it's on that side.
Okay. Cause I was like, how is this possible? Yeah.
So it's going to.
So yeah. Wait, now how did I take it?
How did you do the second part?
What part are you on? What's your record?
You had it where,
I don't know if it's right. I just, you said to just choose one and take it off. And then you just do the same thing. So I think, yeah, you have that right.
okay,
This is the reason we should just. I just
let me see, you take that in carbon.
And then what you do is
That's all I did.
the reason why I got you two right now, you just gonna bring this one down so it can react with this one. And then wherever the minus is, this one's gonna take this carbon. And it's just gonna knock out a bone and all that. That's how it's going. So you have
You follow?
oh, girl, I'm still scribbling on it.
There you go, right there.
Show me what's wrong.
Oh, so you have to buy it. Okay, what I'm trying to figure out, like, how do we connect it?
Something drawn like that right here.
I thought he was saying connect it to this card.
It is connected to
got a
that carbon.
pocket here.
Not right.
Yes, it is. That is that carbon. That's CH3, don't pull out.
Oh,
Oh, but it's gonna be a single bond to our negative. Let me see. Final product, kind of O negative on. But we're connecting this to this.
oh, yeah, that's right. That's right.
You said two.
Right.
Use twice. Use the each twice right here.
Better ask him about it.
You really don't have to do that part right there.
We have to
You
connect.
know how you do this, you know that. You know you want to use this one, right?
It's the easiest one.
One.
Are you getting them, George?
You said that.
Pretty much. I,
Don't worry, don't count these.
okay,
You looking at the same way I was trying to add a CH3 to a CH3.
yeah, that was like,
Count from the carbon and tax that, and do it sideways.
okay, cool.
Stop what you're doing and help her out.
Yeah.
Help her. Share what she's doing.
I don't know.
Go through them.
This is same thing. It's like one up here. Oh, this is something. It's just like a substitution. No.
So what's that? Wait, so when we're making this inlet ion, the alpha carbon, it's gonna be this?
I'll talk slow. Double body. You got 3 cards.
So yeah,
CH3, CH3.
So that's what I did.
That's the thing about it right there.
Started on the order like how to change the code. That's all it is. That is
This is the one
That's the
So it's gonna be exactly like.
Yeah, it's gonna be that thick.
Right here, right?
So now,
This attacks this.
Yeah, that's what I mean, right?
This attacks the carbon.
Okay.
And this goes away.
it's going to attack which one?
No, he's the one right there.
Oh, right.
Make it negative.
So this attack is to attack the carbon.
Here's the first one. We didn't get it. I got that by now.
No, just H. Yeah, put H right there. The third one right here, right? Yeah, you can just put that.
Is this what you did?
And think about it, obviously you can look at this. This is here, right? This is the carbon.
Yes, negative.
Attacks the carbon.
Then you attach the part right here.
This is
To that part of carbon. Yeah, you get that. CH. CH.
Okay, he's gonna put the second one up now.
Like that.
I need some rejection.
Like that. So that day, and then you say you're gonna do 1, 2, 3, 5. Yeah, come on. This is I'm going to take 1 off. Yeah, you gonna have.
Okay, stand back. What's one thing he needs to do here?
Add a hydrogen, alpha. Okay. Yeah.
Good job. Okay, so see how in these answers, the alpha hydrogen that attacked has lost a hydrogen, or the alpha carbon that's attacked has lost a hydrogen. Okay? This was a CH3, now it's a CH2. Okay. We've got one more left. Anybody want to do that? Question? Come up to the board and show me.
We're writing it like this, you wrong. Is my question.
But this is the first one. This is the first one, second. This is the first one. Oh, that's one of the two.
Okay, stand back
Yeah.
so everybody can see. Stand over here. What's wrong with that? Get out of the way.
Is it supposed to still be?
What's wrong with this? Missing a hydrogen. It's missing a hydrogen here. You don't take off a hydrogen off that one. That should be a CH3.
Oh, it's still
The way I wrote it slightly.
Well, then, correct.
So would that still be right?
Oh, yeah. Yeah.
Oh,
Okay.
okay.
So all you did, all you did was maneuver the molecule. It's just like taking this yardstick and twisting it around. It's still the same yardstick no matter what angle I look at it. That's all she did with that.
All you doing is you get
Okay.
that group.
Anybody want to do the last one? George. Very good. The last one was the easiest, wasn't it? Because you didn't have all these CH3s, CH2s to carry around. Okay? So by the time you got to number 3, that should have been a piece of cake. Any questions on that one? Okay. All right. Now we're going to take this reaction to the next level. Okay? Which is not that bad. What we're going to do is what's called Aldol condensation. Aldol condensation. Okay? All we do here is we heat the aldol to lose water. Okay? All right. So let me show you what I mean here. Okay, I'm going to erase this part of the reactions. I'll leave those aldols up there. Let's look at this aldol here. This is the one that we made in the beginning. Okay, so this is our first aldol that we made. Okay, what happens is when you heat the aldol, okay, it condenses, which means when you condense air, it loses water. Here we lose water across the alpha and beta carbon. And what forms in there is a double bond. Okay. So we lost water. Okay. So we form this double bond. The double bond is between the alpha and beta carbons. And so here we get what's called an alpha beta unsaturated aldehyde. Okay? You can have alpha beta unsaturated ketones as well if this was a ketone. Okay, but here it's an aldehyde. Okay? So now what I'd like you to do in the last minutes is draw the condensation products for the aldols that you just formed. Okay? Draw the condensations for these. And I'll ask people to come up for those.
You can't use nothing but a CH because you have to use the carbon. There's only one carbon. So that one CH next to it, that's gonna be the alpha, and that's gonna be the beta next to it. Yeah, because you couldn't make this alpha bond. Look at what you need. Do what you need. You see what I'm saying? This is alpha. This is beta.
Anybody want to come up with the first one? Okay.
Is that a long paragraph? Show y'all the number one. Where's the alpha?
Okay, very good.
So there's a CH figure right here? Where did that come from?
Okay, any questions with his first one? Who wants to do the second one?
Dr. Can I ask you a question about the first one?
Yeah.
At the end of it, where did do we automatically get rid of the H that was on CH next to the aldehyde?
Right. So you lose the H on the alpha carbon
Okay.
and the OH next door.
Okay, thank you.
Just like here, I lost H on alpha, OH on beta.
Okay.
You may want to do the second one. Okay. So here, on the second one, you lose one of these and that OH. Okay, so here you get this. It's a ketone, so this is an alpha beta unsaturated ketone in this case. Okay, and the last one, we lose the hydrogen and OH here. Okay. So we get another alpha beta unsaturated ketone. So the double bond forms there. Okay. How many of you got the last one? Okay, about half. Okay. So this is what happens if you heat. Remember, triangle means heat. If you heat the aldol. Okay. All right, so as we finish up class, also make sure that you can go backwards in these reactions. You see, if I gave you this alpha beta unsaturated aldehyde, be able to tell me what the original aldehyde was, two of those reacting. Same thing here, what the two ketones were that reacted.
Dr. Miller, can you label the alpha and beta carbon on that last one?
Here,
Mhm.
alpha, beta. Alpha. Okay. Any other questions on that? All right. Okay, well, let's stop here and we'll look to see you at exam time. Is there a room?